In this video, we're continuing section 4.2 on maxes and mins, and we're going to do this example here. Okay, so this example falls into this section where we're going to talk about, well, what if the min or the max doesn't necessarily happen at the vertex of the parabola? Okay, so we'll see a situation of that happening in this example. Okay, so what does this example say? So a piece of wire that's 10 meters long is cut into two pieces. Length x is one of their lengths, and length 10 minus x is the other length. The piece of length x is used to make a circle, while the other is used to make a square. So part A says, express the combined area as a function of x. And then in B, just to preview it a little bit, we'll get the radius of the circle so that the combined area is minimized. Okay, so eventually we're going to be finding a min of something. Okay, so eventually there's going to be a max-min problem. And, to get it started, our first step is often we try to, for part B, it's like, oh, okay, I know I'm going to minimize something. So part B, I know I'm going to minimize. We identify what it is we want to minimize or maximize, and we minimize the area. So that's usually step one of a max or min problem. Identify the thing we want to maximize or minimize. But step two, and this is what's going to come in for part A here, is we try to draw a picture. So what would I draw a picture of? Well, we have this wire, so I'll draw a wire. Okay, so I'll just draw this line representing this wire, and then it's cut into two pieces. I don't necessarily know it's cut into halves, like equal halves. I'm deliberately going to put the cut a little bit to one side. Okay, and I know the whole wire has a length of 10. The whole wire has a length of 10, and then it tells me that, well, one of the cut pieces is length x, which means the other piece is length 10 minus x. All right, and if we were to test that out, if we add x to 10 minus x, well, they add up to 10. They give me the whole length, which is good. Okay. So what else does it tell me here? It tells me, well, the piece of length x is used to make a circle. So this first piece that has length x, that's used to make a circle. So I'd sort of bend that wire, and it's going to make this circle. And then the second piece is used to make a square. So if I bend that second wire is used to make a square. Okay. So part A is asking me to get the combined area as a function of x. So combined area. So I need some equation for area, and the area needs to be just in terms of the variable x. Okay, so this I want to give to you all as a warm-up problem. Okay, so I want you to pause the video for about 3 minutes and see if you can get the equation for area here, the combined area of the two put together, just in terms of x. So pause it in 4, 3, 2, 1, pause it. Pause it for about 3 minutes to try this. This is a great practice problem in terms of setting up this equation. It's absolutely doable, but you gotta try it. See how we can tackle this. All right, so hopefully do that. Hopefully pause it for about 3 minutes. If not, definitely do that. It's super important to pause it and try these questions. Okay, so let's talk about it now. All right, so my area, so I'm gonna label the picture a little bit. I'm gonna introduce some variables. I'll need the radius of the circle, so maybe I'll call that r. You know what, let me put it in a different color. So the radius, I'll call it r. I'm also going to need to know the side length of the square, so I'll call the side length s. So my area is, the area of the circle is pi r squared. The area of the square is s squared. And then it wants me to combine the areas, which means add them together. Okay, so I got this area, but it's not in terms of x right now. I need it to be a function of x. Okay, so this right here, previewing part B. In part B, I'm going to try to minimize the area. So if I have an equation for the thing I want to maximize or minimize, we call that the objective. So eventually for part B, this is going to be the objective, but I want to get this in terms of just x. And what's going to help me there is I need a constraint. I need some other equation based off of info I have in the problem. And for this problem, we're actually going to have two constraints. We're going to have two constraints. So from the square, well, I know that the whole wire that made up the square had a length of 10 minus x. So that means if I add up all four sides and get 4s, well, that had to be the length of the wire. That had to be 10 minus x. Okay, so if I isolate s, if I divide the 4 over, we get s equals 10 minus x divided by 4. Ooh, so nice. So I know what s is. Let me start to plug that in my equation. Area equals pi. I'm going to have to think about what r is. I'll just leave a blank parentheses squared. Plus, for s, I know what s is at this point. I know s is that 10 minus x divided by 4. Nice, I got that part at least in terms of x. But I need to get this first parentheses in terms of x, so I'll need another constraint. So knowing the total length of wire for the square was helpful because I could use the perimeter. Now let's do the same thing for the circle. Well, if I bend that wire all the way around, it gives me the circumference of the circle, and the circumference is 2 pi r. Well, the whole circumference had to be the length of that piece, which is x. So 2 pi r had to be x. That was how long of a piece I had to make the circumference. All right, so if I isolate r, I can divide the 2 pi, and I get r equals x divided by 2 pi. All right, so nice. So I know what r is. I'm going to plug that in. I get x divided by 2 pi. X divided by 2 pi, that is r. And at this point, I got the area as a function of x. That's what it wanted in part A. So part A was basically saying, let's just break the problem down a bit. I'm going to just get the objective. All right, so part B now, we're going to do the heart of the algebra. Now we're going to find ultimately the radius of the circle that makes this combined area be minimized. Okay, so I want to minimize this thing. All right, so I'm going to have to start to do some algebra to it. So I got area equals, I got pi, and then if I square that first fraction, I can square the numerator to get x squared. And if I square the denominator, I get 4 pi squared. 4 pi squared. Okay, and let's square out the next term as well, this fraction. So on the numerator, I'll have to FOIL out 10 minus x squared. 10 minus x times 10 minus x. And if I FOIL it, I get 100 minus 20x, and then plus x squared. And on the denominator, I get 4 squared, which is 16. Okay. All right. So what I want. Okay. So let me simplify this a bit further. So let's see. I got area equals, and I notice in the first term I can cancel a little bit. I can cancel this pi with one of the pi's on the bottom, and that'll leave me with pi here. Okay. So overall, the first term becomes 1 over 4 pi, and that is the coefficient of x squared. Okay. Nice. So now this fraction, I can split it up into pieces. It becomes 100 over 16, and then minus my next term, 20x over 16, and then the last term, which is that plus x squared over 16. And if I think about it, that's the same as what I just had. Because if I got all these common denominators, now when I'm subtracting and adding, well, that would just give me back this if I were to combine it all together again. Okay, so I was just doing that in reverse. I was splitting the fraction up into pieces. Okay, so I noticed that we're getting a quadratic here. And I know we find maxes and mins of quadratics ultimately by completing the square. But to do that, I gotta figure out what the coefficient of x squared is. But I see a couple of x squared terms. There's an x squared term here, and there's another one there. So I'm going to have to combine them. Those are like terms. Ooh, okay, so I'll have to combine them. So I'll get area equals. So what I'll do is, out of those two terms, I'm going to factor out an x squared. And if I factor out x squared, I'll be left with, from the first one, 1 over 4 pi. And from the second one, I'll be left with 1 over 16. So plus 1 over 16. And then after that, I'll write the x term. So for the x term, I can cancel a 4 on the top and the bottom. And that'll leave me with minus 5 over 4. I'll just write the fraction in front and then times x, just so I can more clearly see the coefficient of x. And then finally, I got the other fraction term, the constant. I can also divide that one by 4 on the top and the bottom to get 25 over 4. Okay. All right. Okay. So now, with my x squared coefficient, I'll have to get a common denominator to add these fractions. So for the first fraction, I got to multiply it top and bottom by 4. And that's going to give me 4 on top and 16 pi on the bottom. I just multiply the top and the bottom by 4. The second fraction, I'd have to multiply the top and the bottom by pi. And that gives me pi over 16 pi. And now that I got a common denominator, I can add these. I get 4 plus pi on the numerator and just 16 pi on the denominator. All right, okay. So we got this thing. All right, so I want to continue this on to the next page. At this point, I can see I got this quadratic. It's not the nicest looking quadratic. I mean, I got fractions galore. Everywhere there's fractions. And one of these fractions is especially tedious looking. I got some pi's in it. I got things added in the numerator. So this is going to be a little bit more of an algebra intensive problem to get the vertex. Remember that we are practicing getting the vertex by completing the square. So I want us to practice doing it by completing the square. Okay, that's what I'll ask you to do on all of our homework problems involving these max-min problems. I'll ask you to do it by completing the square. And I want you to be able to do that for a quiz if I were to ask it. So even now, I want to practice doing this by completing the square. If you know the vertex formula, for that x coordinate, which is like x equals negative b over 2a, you could use that to check your answer, but I'll be direct in the instructions on the homework that I want you to complete the square. But we could use the vertex formula to check our answer. Okay, all right, so I'm gonna have to complete the square with this. All right, so because I have this leading coefficient and it's not just a 1, well, the first thing that I do when I complete the square, I'm now ready to start completing the square, is I gotta factor that leading coefficient out of the first two terms. So I'll get a equals, let's factor that coefficient out. Let's factor out that 4 plus pi over 16 pi. I'm going to factor that out of just the first two terms. Just the first two terms. So that'll still leave me with the plus 25 over 4 at the end. Okay. So if I do take this out of the first term, I'll be left with, I still got the x squared there. So the second term, it's a little bit harder to see what's going to be left over there. So remember the way we do that, if it's a little bit unclear. We can first write what's there right now, which is minus 5 over 4x. And that's going to be divided by what we just factored out. We just factored out 4 plus pi over 16 pi. And as a reality check, anytime I factor out like that, well, if I were to take this and I were to distribute back to the x squared, and if I were to distribute back here, well, when I distribute it to the second term, it would cancel this denominator out and leave me with that minus 5 over 4x like I had before. And that's good. Okay. All right, so let me just erase some of these distribution symbols. All right, so now, okay, so I'm getting this. Let's simplify. So I got this fraction divided by this other fraction. Let's work out what that is. So we'll get, what do we get? Let me include the negative sign here. We got negative 5 over 4x. That's getting divided by a fraction, which is the same thing as multiplying by the reciprocal. 16 pi over 4 plus pi. Same thing as multiplying by the reciprocal. Okay, and I can cancel a little bit. This 4 on the bottom can cancel that 16. I can divide each of those by 4 to be left with a 4 here and a 1 there. So now when I multiply these, on the top I got negative 5 times 4 pi. So that is negative 20 pi. And on the bottom, I just got 1 times 4 plus pi. That is just 4 plus pi. Oh, because that just becomes this. So let's write that on the next line. Area equals, in front I got 4 plus pi over 16 pi, parentheses, x squared, and my fraction became negative 20 pi over 4 plus pi. Over 4 plus pi. Oh, okay, whoops, and I forgot something. Sorry, what I forgot was this x. So when I multiply, that x is still there. Okay, let's not forget that. That x should still be there. Nice. All right, cool. Close that parentheses. And I still got this plus 25 over 4 at the end. All right, so that is the first step of completing the square. This leading coefficient of the x squared, whoops, that leading coefficient of the x squared, we factored it out of the first 2 terms. Okay, so when we did that, we got to where we are now. Well, next when I complete the square, we look at this coefficient of x. And I got to divide that by 2, and I got to square that thing. Okay. You know, it looks like it's going to be a little bit tedious, but we can handle this. It's just some fractions. We just got to be careful. We can handle this. So let's see. We're going to get negative 20 pi over 4 plus pi. So if I'm going to divide this by 2, I'm going to erase that in just a sec. But if I divide it by 2, that's the same thing as multiplying by the reciprocal of 2, which is a half. So dividing by 2 is the same thing as multiplying by 1/2. All right, so doing this, I can cancel a little bit. I can divide both the 2 and the 20 by 2. That'll leave me with 10 up here and a 1 down there. So negative 10 times 1, I get negative 10 on the top. And on the bottom, I just get 4 plus pi. I get 4 plus pi. Okay, that's the first thing I got to do. I got to divide it by 2. Next, what I got to do, I'll put an arrow next to it, is I got to square that thing. Now I got to take this value, negative 10 over 4 plus pi, and I got to square this thing. I got to square this thing. And you know what? I'm realizing I forgot something. Just a small thing. There was still a pi here, so I forgot to write that on my numerator. There should have been a pi here, and therefore there should have been a pi there. Okay. All right, now let's square this thing. So squaring it, well, if I square the negative, it goes away, it comes positive. And then if I square the 10, I get 100. I also got that pi squared. And the bottom, for right now, I'll just keep it as 4 plus pi squared. I won't FOIL it out. Maybe later stuff will cancel. A bunch of stuff seems like it's canceling a bit, at least. So maybe I'll keep it like that and stuff will cancel later. Okay, so I'm going to put this work that I'm doing on the side. I'm just going to separate it out a little bit. This is just some scratch work to figure out what happens now when I complete the square. So now this number I got, that's what I'm going to add, and I'm going to subtract it inside the parentheses. So we got area equals 4 plus pi over 16 pi, parentheses, x squared minus 20 pi over 4 plus pi x. And now I got to add the number I just got. I got to add 100 pi squared over 4 plus pi squared. And I got to subtract it. And I got to subtract it minus 100 pi squared over 4 plus pi squared. I got to subtract it inside the parentheses. Okay, cool. And then I still got the plus 25 over 4 at the end. Okay, so when we do this, assuming we did our calculation right, these first 3 terms here should factor as a perfect square. This should become x and then something squared. Okay, so what's the number that goes here? How do I factor this perfect square? So it looks tricky because I got all these fractions. But if we remember our trick, our shortcut from class, it's really quick. So the shortcut, remember, is, well, the number that goes here, this perfect square, is always what we get when we divided that one term by 2. And after we divided by 2, that was this. That was, I'll put it in a darker color, negative 10 pi over 4 plus pi. That's what's got to go in that parenthesis. So I put that minus 10 pi over 4 plus pi. And if I were to test it, if I were to FOIL out this perfect square, well, we would get these three terms. Okay, so that is that shortcut. It's really helpful in these completing the square things to identify, well, what's the number that goes here, especially when we got these fractions. Cool. So we got that. So next up, what we do is this leading coefficient, well, I'm going to have to distribute that to the first three terms and also distribute it to this last term. Okay, so let's go ahead and do that. So we'll get area equals the leading coefficient 4 plus pi over 16 pi. That'll get distributed to the perfect square. The perfect square was that x minus 10 pi over 4 plus pi quantity squared to the perfect square. And then it also gets distributed to the last term. Okay, so, well, this thing is positive, so I need to put a positive sign. So plus 4 plus pi over 16 pi. And that fraction is multiplying that last term. It's multiplying the negative 100 pi squared over 4 plus pi, that quantity squared. Okay. All right, so I'm completing the square. This part of completing the square is kind of taken care of. We kind of have that part done. But it's the stuff out here now, I got to simplify it further. Okay, so the stuff out there, let's try to simplify it. So there's some stuff that's going to cancel. Like I notice this 4 plus pi, I can cancel with one of the 4 plus pi's on bottom, and that'll leave me with the 1 up here, and a 4 plus pi down there. Okay, so that leaves me with, if I multiply, I got, so let's see, this is a positive, that's going to multiply the negative. That'll give me negative 100 pi squared over, on the bottom, I still got 16 pi times 4 plus pi. Okay, now I'm realizing there's one term I forgot to write on this step, which is I had this 25 over 4. I just forgot to carry it down over here. That should still be there. Still got that plus 25 over 4. Okay, so we have just been simplifying this part right here. I can cancel some more. What can I cancel? I can divide the 100 and the 16 by 4 to be left with a 4 down here and a 25 up here. I can also cancel a pi. That'll get rid of this pi entirely because that's factored out. And then the pi squared, if I cancel that by pi, that'll leave me with a pi. Okay, so what do I have here? What do I have here? So this becomes negative 25 pi over 4 times 4 plus pi. All right. And I'm going to have to add this to, the 25 over 4. So I'll have to get a common denominator. So let's get a common denominator with this. I'll have to multiply this 25 over 4, top and bottom, by this 4 plus pi. So that'll give me 25. It'll give me 25 multiplied by 4 plus pi. And then over the 4 multiplied by 4 plus pi. So I'm multiplying the top and the bottom by 4 plus pi. Okay, and there's the plus sign. So this is going to get added. Okay, so we're adding, and let me distribute this 25 in. So that'll give me 100 plus 25 pi all over the 4 times 4 plus pi. Okay, so we're almost there in terms of simplifying this. Now that the denominators are the same, I can add these. And when I add these, the 25 pi's, this one's positive, that one's negative, they're going to cancel. And we'll end up with 100 on top over 4 times 4 plus pi. I can cancel a little bit more with the 100 and the 4. I can divide both of those by 4 to leave me with 25 on the top and just 4 plus pi on the bottom. Okay, so that was what I got when I simplified all of this. Took me a few steps of algebra to get it, but it simplified quite a bit, which is nice. All right, so let's write what we have. So I got area equals, we get that 4 plus pi over 16 pi in front And that's multiplying my perfect square, x minus 10 pi over 4 plus pi. That was that perfect square portion. And at the end, now I was left with plus this 25 over 4 plus pi. I was left with that. Okay, this is now in vertex form. It is now in vertex form. Okay. Running out of room here, so I'm gonna move this up a smidge. I'm gonna move this up a smidge. All right, so let's write the vertex. Vertex. So the x coordinate is what I plug into here for the x to make the perfect square part be 0. And I would plug in 10 pi over 4 plus pi. And if I do plug that in, well, this whole part becomes 0, and we'll just be left with this. Okay, so that's going to be the y-coordinate of the vertex. The y-coordinate is going to be 25 over 4 plus pi. So 25 over 4 plus pi for that y-coordinate. Remember, anytime I do these max-min problems and I get the vertex, I should identify what variable goes with each coordinate. So for this coordinate, this is the x-coordinate of the vertex. And in my equation up above, well, I still got x as the variable there, where x usually is. Okay, so that means this coordinate is still going with the variable x. My y-coordinate, well, in my equation, I don't have y. Where y usually is, I have this variable. So that this is representing a here rather than y. Okay, so I know my vertex. I know what variable goes with each of these things. Let me just look back to what was the problem asking for. It was asking me to find, let's see, the radius of the circle. Remember, the circle is kind of what we formed when I split up my wire into pieces, and one of the pieces became a circle. So what radius of the circle would make this area be a minimum? So part of what I got to do is make sure I justify, well, why is my vertex going to be a min? Why is it a min and not a max? So let's check our parabola. And if I look at the parabola, well, here's the leading coefficient. So based on that leading coefficient, we call that A. A is a positive number. And if that's positive, we have an upward facing parabola. An upward facing parabola. And if it's upward facing, I'll draw a picture. Upward facing parabola. Well, at my vertex we have a min. So we have a min at the vertex. And that is what I want for this question, at least for part B. I want to find a min, and I know that's happening at the vertex here. Okay, so I just got to make sure now that I answer what this problem asked for, and that is it wanted the radius. It wanted the radius. So how could I get the radius? Knowing, well, I know what x is, and I know what a is. How can I use that to get the radius? So I had an equation. For the radius. I'm going to try to get the radius. And my equation for radius, let's scroll it up, was one of my constraints. It was, let's see, it was here. Radius equal this. Radius equals x divided by 2 pi. So I can use that. So radius, for my constraint, radius equals x divided by 2 pi. And I know what x is, so I'm going to plug it in. I know what x is. X is going to be 10 pi over 4 plus pi. That's x. And when I divide by 2 pi, well, that's the same thing as multiplying by 1 over 2 pi. Okay, so this can be simplified. So I can cancel pi's, and with the 10 and the 2, I can cancel those a bit. That'll leave me with a 1 here and a 5 up here. So on the numerator, I just end up with 5 times 1, which is 5. On the denominator, I get 4 plus pi times 1, which is just 4 plus pi. Ooh, okay, so this is r. This is my radius. I just have to make sure I put units, and the units of length in this problem were meters. So this is the radius of the circle that would give me a minimum combined area. Okay, so this was a long problem. So we just finished part B. Okay, so there's another part to this question. What if I want to get the max? What if I want to get the max total area? We just got the minimum. What if I want to get the max? Okay. So this one's weird because we have an upward parabola. We have an upward parabola because the leading coefficient is positive. So if I draw a picture and I put some axes on this. Okay, so if I draw a picture and I label my vertex. So I had this vertex over here. Well, I know the x-coordinate of the vertex is at 10 pi over 4 plus pi. That's the x-coordinate of the vertex. And the y-coordinate, this thing, I mean, technically I should say it's the a coordinate. The y-coordinate represents the variable a. Okay, but that is this number 25 over 4 plus pi. Okay. I don't really need to label that in the picture. I just care about this x-coordinate for right now. And the fact that it's an upward-facing parabola. So if I draw my upward-facing parabola, something like this. Something like this. Got to make it symmetric about that vertex. Well, with an upward parabola, I know where the min is because we just got it. The min is at the vertex. What about the max? Well, the max, in general, if my parabola just kept going and going and going and going in both directions, this way as well as this way, well, there would be no max. It just keeps getting higher and higher and higher. But if my domain is sort of limited, like if I was kind of limited to like a domain like this, well, then I would just be looking at a small part of the graph. And on a small part of the graph like that, I could have a max. Okay, so, well, what would determine that max? The max could happen at an endpoint. The max could happen at an endpoint. So what do I mean by endpoint? So for my x variable, so this coordinate, this axis, sorry, corresponds to the variable x. The y-axis actually corresponds to a, the area. Well, let's think about an interval for x. So what was x representing? So x was, if I go way up to the top to my picture, x was the length of one of the pieces. It was the length of one of the pieces. So let's think about the smallest that could be and the biggest it could be. So if the whole wire was 10 meters long, the smallest one of the pieces could be is 0. Because if x was 0, that just basically means the circle is not really there. It's just a dot. And everything is the square. So the smallest x could be 0. And it could be equal to 0. If it equals 0, then, well, one of the pieces is kind of non-existent and everything is the other piece. And what's the biggest x could be? Well, that's 10. 10 would be the flip side of that. That would mean everything, the whole thing is a circle and there's nothing left over for the square. That's my interval for x. Okay, so let's identify where those two coordinates are, the 0 and the 10. Okay, so, well, I know 0's here. So I know what this distance is. I know the distance from here to here is just 10 pi over 4 plus pi. And what I need to know is, at that other endpoint at 10, like is 10 somewhere here? Because if 10 was there, then I'd just be looking at this part of the graph. And on that part of the graph, I could clearly see that the max would happen at this endpoint of the interval. Okay, but we need to know exactly where 10 is. So is 10 somewhere there? Or is 10 way out here? Because if 10 was way out there, well, then the y value at 10 is going to be way higher than the y value at 0. Okay, so I basically need to know what's closer to that vertex. Is 10 closer or is 0 closer? Okay, so, well, to figure that out, I know 10 is going to be somewhere out here. Let's subtract the bigger number minus the smaller number, minus this vertex. So let's do 10 minus 10 pi over 4 plus pi. So I'll have to get a common denominator. So common denominatoring this, I'll have to multiply the 10 top and bottom by 4 plus pi. So 4 plus pi over 4 plus pi. So doing the multiplication, I can write 10 as 10 over 1. And if I distribute 10 to the 4 and to the pi, I get 40 plus 10 pi over 4 plus pi on the bottom. And then I got minus 10 pi over 4 plus pi. Okay, so that equals this when I'm subtracting. And then now that the denominators are the same, I can combine them into one fraction. But the plus 10 pi and the minus 10 pi will cancel. And it'll leave me with 40 on the numerator and 4 plus pi and 4 plus pi on the bottom. Okay, so that's saying wherever 10 is, the distance between my vertex and 10, however far 10 is, I don't know necessarily yet, but that distance needs to be this, 40 over 4 plus pi. So I need to compare that. I need to compare this with, let me go to highlight mode. I need to compare, is this distance bigger? Or is this distance, I need a different color for that one. Or is this distance over here bigger? So they got the exact same denominator, but which numerator is bigger? So which numerator is bigger? Is 10 pi the bigger numerator, or is 40 the bigger numerator? Question mark. So pi is about 3.14. So this is approximately 10 times 3.14. And if I multiply by 10, it moves the decimal over one spot. So I'll get 31.4. So the 10 pi, that numerator is about 31.4. That is definitely smaller than the 40. Which means this distance wins. This distance is the bigger distance. Okay, so let's label that distance here. The distance 40 over 4 plus pi is a bigger distance. Okay, so that means 40, the x-coordinate 40 is further away from the vertex than 0 is. Okay, so this is the bigger distance. This is the bigger distance from the vertex. Okay, so we are just looking at the part of the graph that's in between where x is 0, that's over here, this endpoint. All of this, all of this, all of this, all of this, until I get to where 40 is. Well, 40, because that point is further away, that's going to reach a much higher point on the parabola. It's going to reach a much higher point. Okay, in fact, that's where the max is going to be. So my max is happening when x is 10. Okay, all right, so I got to use this x value to figure out, well, what is the area? It said, what is the area? Okay, so I got to take my area equation, which we had before. I'm just going to write it down one more time. It was pi times x over 2 pi squared. That was the circle area, plus 10 minus x over 4 squared. And that was the square area. And now let's plug in what we know x is. So we'll get pi times x is 10. I get 10 over 2 pi squared. And I'll plug in 10 into the next part. Well, if I plug it in the next part, 10 minus 10 is 0. I'll get 0 over 4 squared. But 0 divided by 4, that's just 0. And if I square 0, that's just 0. So this part just becomes 0. Okay, that's nice. And in my first fraction, I can divide the 10 and the 2 by 2. That'll leave me with the 1 here and a 5 up there. And now let's simplify. I got area. So this equals, let's see, I got pi times, and now I square this fraction. If I square the 5, I get 25. On the bottom, I'm just left with pi. If I square that, I'll get pi squared. I'm almost there. Just got to cancel the pi. And I'll get 25 on the top over pi on the bottom. Okay, and this is my maximum area. I just need the units now. And the units of area here were meters squared. Meters squared. That is my maximum area. Let me just do a quick check. In my last part, did I include units? Oh yeah, I got meters over there. Okay, so the big takeaway from this is, if I'm looking for a max or a min, and it doesn't happen at the vertex, well then it might be happening at an endpoint. And that's what happened here. That might be happening at an endpoint of my interval. Okay, so I fully expect that this was a challenging example. This is one of the toughest examples that we're going to look at in our class. So I don't expect that you would have followed everything on this first go around. You definitely want to go through this again in your notes at your own pace, make a note of questions that you have, and then bring those to drop-in and bring those to the MLC to ask about them.